Hey, this is Mr. James, and this video will be doing a tutorial on how to perform a translation. So let's start up at the top here. Below is a translation. We'll typo, just cross that out, right? Translation. So below is a translation. Connect the points of the pre-image to the corresponding points of the image. Then answer the question below. So they've already done one for us. It says C to C prime. So let me just go and connect the other ones. B to B prime, D to D prime, A to A prime. Great, okay, did that, check. Now let's answer the question. Measure A to A prime, B to B prime, and D to D prime. Okay, we need centimeters for this. So A to A prime looks like about 3 centimeters. Yeah, 3 centimeters. Let's see over here. Okay, that's 3 centimeters, and okay, that's also 3 centimeters. Okay, what do you notice? Well, hopefully you're noticing that all segments that we're talking about, at least, are 3 centimeters. They're all congruent. Okay. Now this segment that we drew is called a vector. Okay, it's called a vector. V-E-C-T-O-R. And we need a vector to do a translation. A vector tells us two things. It tells us the direction we're going in. So it could be up, down, sideways, this kind of diagonally. Okay? And it also tells us how far, or the distance, we're going to move our polygon in. Okay? So those are the two things we're going to need from a vector. Okay? And often we represent it just by this line with an arrow on one side, similar to a ray. Okay? And that's basically what a translation is. We're just taking a shape and moving every point on that shape, on that polygon or whatever have you, with a certain direction and a certain distance. You may have seen vectors before on maybe a grid. If I had maybe a square over here, and I wanted you to move down 6 squares, that's actually a vector. It's telling me down, that's my direction, and 6 squares, that's my distance. So if I had to move down 6 squares, 1, 2, 3, and then maybe add some more, 4, 5, 6, and you keep going. That is a vector, again, because it has direction and distance. First, we're asked to draw one translation vector on each pair of pre-images and images below. So all it's asking you to do is draw that kind of ray from one point on the pre-image to one point on the image that corresponds. So for example, that right there is a vector. And it only asks for one. That's all you need to do. If you want to fill in the other ones, you could, right? You could fill in all the other ones. But it only asks for one, so I could have stopped in the beginning, but I guess I'm already going. So, arrow. Make sure you draw them as rays, because vectors have that direction to them, so you need to make sure we have that direction. Okay, pause the video here and try and fill in the vectors for the next two images and pre-images. Pause the video now. The answers will be coming up in 3, 2, 1. And here we have our result. You only had to do one vector, but I've put all of them in for all the different vertices. Get a little carried away here. But one interesting thing to notice about this second or third problem over here is that the vectors are actually running along or parallel to the sides of the triangle. Okay? And that's going to happen sometimes where we're actually shifting this or translating it parallel to the side of our polygon. The next set of questions asks us to translate the polygon by the vector AB in all 3 figures. Now, this is going to get a little difficult because in previous videos we've done this tutorial, we've used the compass and the ruler to help us move things down, right? However, it's a little difficult here because when we're talking about translations, all of the vectors have to be parallel. If you look back up at the previous set of questions, notice how all of these vectors are parallel to each other. And that's very important, that those vectors are parallel. Okay? And again, over here, all the vectors are parallel going in the other direction. Okay? So how can we deal with things that are parallel here? Well, we are going to use our patty paper to help us. So take your transparent patty paper and place it on top of your figure. Okay? You're going to have to use a pencil for this because pens don't write very well. and we're going to trace my figure. A, B, Z. Perfect. Now it says translate by the vector AB. So I'm just going to take a colored pencil and draw that in here. It wants me to do this. A to B. So what I'm going to do is extend my line A to B a little bit so I can just get a better sense of the direction I'm moving in. A little longer. Okay. And then shift this down until A touches B. So I'm moving it down like this, keeping the line, right, in line right there. And once those hit each other, I'm finished with my translation because I've moved the vector A to B. See? I'll do it again. A has moved to B. Okay? And everything else has stayed parallel. So I'm going to press down a little hard right here so I can go through the transfer paper. Okay? Oh, I might actually have to rip it a little bit to get through this one. Okay. 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 And now that I've plotted my points, I can go ahead and draw everything in just like this. Okay. And you can see I moved the vector A to B, so that's not A prime. B is moved down here, and Z is moved right here. The next one is very similar, although I'll do one more just to show you how to do this. Again, we'll take our transfer paper and trace our triangle to be moved. Okay, it's P1, P2, and P3. And I'm also going to trace my vector from A to B, and that's how long I'm going to go, from A to B. To be able to move this parallel, though, I'm going to make this line a little longer so I can keep everything in line just like before. Okay, and move the vector A to B. Once I hit B, there it is. See, starting here, moving the vector A to B. Once I hit there, I have finished my translation. I can go ahead and plot my points, just like that. Okay, and connect. And I've translated triangle P1, P2, P3 by the vector AB. P1 prime, P2 prime, P3 prime. Go ahead and try and translate this third polygon right here. The answers will be coming up in 3, 2, 1. All right, and here is our result. A couple interesting things to note is that this one, similar to the first one over here, is being translated along a vector that's actually part of the polygon. So we actually moved up in this direction right here. So I moved my paper up until I got to here. And another interesting thing is that A prime is now on B, and H prime is now on G, because they both moved up parallel to each other. Again, important thing to remember here is that translations, all the vectors for translation are all parallel. They're all moving in the same direction, We have one last thing to talk about with the translations, and that is translations on a coordinate grid. Now these are actually much easier than the translations you've done before without a coordinate grid, so this is a little bit of a break. Before we start though, we need to know what this notation means. We know that the capital T means to translate, but this down here, these parentheses 3, -4, isn't a point. Instead, it's a vector. Remember, vectors have direction and magnitude, or distance. So this vector tells us to go right 3 in the x direction, down 4 in the y direction, which makes sense because our points are always x, y, and so this gives us the vector, how far to go in the x direction, +3, how far to go in the negative direction, or the y direction, -4. So let's go ahead and do one of these. 7 says to translate r, that's point r right there, by the vector 0, 6. Now the first number is the x direction, the left and right, and so it's 0, we're not going left and right at all. But the y direction, the second number, is 6. So that means we're going to go in the up and down direction, the y direction, 6 up. There's two ways you could do it. You can either just count 1, 2, 3, 4, 5, 6 up right there. 6 doesn't hurt to double check, and draw r prime. Or, if you prefer using patty paper, you can place your patty paper over here, draw your point r there, and then count 1, 2, 3, 4, 5, 6 that way. It's up to you. This next one is a larger triangle. We're going to translate all 3 points, P, Z, and L, by the vector 2, 0. So that's 2 in the x direction and 0 in the y direction. So not moving up and down at all, because it's 0 in the y direction, but the x direction, left, right, I'm moving 2. Now, positive 2 means we're going towards the right. So one method is take every point and just translate it 2 to the right. 1, 2, and I get L prime. 1, 2, and I get Z prime. 1, 2, and I get P prime. And then I can go ahead and connect those points, okay, to get my image here. Now again, another option is to take your patty paper, draw your pre-image or trace it on there, and then translate it as a whole. 1, 2, over. That's an option as well. What I'd like you to do now is pause the video and try and do number 9 here. As a hint, remember, -5 in the x direction. Will that mean go to the left or go to the right? -3 in the y direction. Will that mean go up or go down? I'll let you decide, but the answers will be coming up in 3, 2, 1. And here's our result. Now again, you could just notice that -5 in the x direction means to go to the right. So 1, 2, 3, 4, 5. And -3 in the y direction means to go down. 1, 2, 3, and there's R prime. Do that for every point and you get your image. Alternately, use your patty paper and count all the points at once. 1, 2, 3, 4, 5, and down 1, 2, 3 to get your image. Either way works, but hopefully you've learned how to translate on the coordinate grid using vectors.